Howdy. This video will focus on the vertex form of the quadratic equation. The vertex form of the quadratic equation is this equation right here. We have y equals x minus h squared plus k. And this looks an awful lot like the transformations, right? Whatever's on the inside, we have an inside, and we have an outside, okay? Now, in order to find our roots, we still need to graph our equation. For now, later on we'll find out how to find the roots without graphing. But with the vertex form, we can find our axis of symmetry and our vertex without graphing. Our axis of symmetry will be just x equals h. So whatever is right here. Now notice we have a negative h, but we don't have a negative here, do we? We don't. So whatever's on the inside, our axis of symmetry will be whatever h is, but without the negative sign. So if it was positive, so if we had an x plus h on the inside, then our axis of symmetry would be x equals negative h, okay? And our vertex, same thing, is going to be hk. So it would be h without the negative, bring it down, and then our k in an ordered pair. So it would be whatever h is, bring it down, h, whatever k is, bring it down, and then ordered pair. Same thing, if we had a positive h on the inside, we would get rid of that positive and make it negative, so it would be negative h and k in an ordered pair for a vertex. Now let's go into a few examples. We have y equals x plus 2 squared minus 3. So our axis of symmetry will be x equals, since we have a positive 2, our axis of symmetry will be a negative 2. Same thing for our vertex. Bring down our h, but instead of positive 2, it'll be negative 2. And then whatever's on the outside, we have a negative 3, so then negative 3. Okay. Now for our axis of symmetry, for our second example, we have a negative 5, so our axis of symmetry will be x equals positive 5. And our vertex will be, bring down the h, that's a negative, so we need to make it a positive, so positive 5, positive 12. Different topic now. Transforming vertex form to vertex form. Before, we only transformed our parent functions. So f of x equals x squared, and we transformed it using, let's say, negative f of x plus 2 minus 3. So then, since we have a negative on the outside, put a negative on the outside. On the inside, we have x plus 2, put x plus 2 squared. On the outside, we have a negative 3, so put a minus 3. There's our transformation. But now, we're transforming our vertex form to vertex form, using this transformation right there. So, on our original equation, f of x equals x minus 2 squared plus 4, that would be a positive 1 multiplied to the outside, right? So on our new transformation, we have a negative 2. So that means we're going to multiply that positive 1 by a negative 2. So our transformation will be negative 2 times 1, which is negative 2. So negative 2, and then in parentheses, bring down what's on our inside. So bring down whatever is inside, so x minus 2. Now, on our inside of this, of our transformation, we have a negative 2. So then just put another negative 2 on the inside. So what's a negative 2 plus a negative 2? That is negative 4. So x minus 4 squared. Now we want to bring down whatever is on the outside of our original equation, so plus 4. And then our transformation, it has negative 5, so put a negative 5. So now what's positive 4 minus 5? That would be negative 1. So our new equation is the transformation of this function using this transformation is negative 2 times x minus 4 squared minus 1. Alright, not too bad. Now, given the equations, describe the transformation. Our two equations, so equation 1 is f of x equals x plus 3 squared minus 1, and it was transformed into f of x equals negative x plus 3 squared plus 2. So from this transformation to this transformation, what happened? So on the outside of this one, we have a negative. Here we don't. So our transformation is going to have a negative on the outside. So negative f of x. Now, the difference between the insides, we have x plus 3 and x plus 3. Nothing happened. So on our transformation, we're just going to have negative f of x, since nothing happened. Now, on the outside, we have a plus 2 and a negative 1. So, what added to negative 1 equals positive 2? That would be positive 3. So we're going to have a positive 3 on the outside of our transformation. So the transformation from our first function to our second function is negative f of x plus 3. Moving on. Oh yeah, and by the way, these questions that I'm showing you may or may not be on the test. So thank goodness y'all are watching these, because y'all have a heads up. Alright? So, 10, 11, and 12. I guess those are 10, 11, and 12 on the test. Who knows? Maybe, maybe not. Our f of x equals x minus 1 squared plus 4. So on this equation, we went left 1 and up 4. So which one of these has a left 1 and up 4? So, left 1. Wait, I'm sorry. That's a negative 1. So it's going to go right 1 up 4. So right 1 up 4, not A. Right 1 up 4. That's B. Say hi to my students, babe.
Hi, students.
Alright. So now, number 11, we have a right 1 and a down 4. So which one of these is right 1 down 4? It's not A. Right 1 down 4. It's not B, because we already chose that. Right 1 down 4. Oh, it's C. Alright. Now our last one. Uh-oh. Mama. Alright. So now, number 12, we have a negative sign. So instead of a upward horseshoe, we'll have a downward horseshoe. Left 1, because of the positive 1. And up 4. So, left 1, up 4, down a horseshoe. It's not A. Not B, not C. Let's try D. Left 1, up 4, down a horseshoe. Okay, D. Alright, so next, final example. This may or may not be on the test in different words. Alright, so a zombie-eating vampire fish jumps out of the water. Its path is described by the equation h equals negative 0.5 times t minus 6 squared plus 18, where h is height in feet and t is time in seconds. So how high will the fish be at 3 seconds? So seconds is time. So in other words, we're going to have t equals 3. So then let's plug in t. We're going to have h equals negative 0.5, 3 minus 6 squared plus 18. So 3 minus 6 is negative 3. Negative 3 squared is 9. So I'm going to have a negative 0.5, 9 plus 18. So then negative 0.5 times 9, so that's 9 divided by a negative 2, is negative 4.5 plus 18. Milo, quit barking. Alright, so now we're going to have negative 4.5 plus 18, and that's going to equal positive 13.5. And that's going to be feet. So the fish was at 13.5 feet after 3 seconds. That's one crazy jumping fish. Now, when will the zombie-eating vampire fish hit the water? When it hits the water, that means it's going to be at height what? 0. So we're going to set h equals to 0. So h equals 0. So we're going to have 0 equals negative 0.5, 3 minus 6 squared plus 18. That's going to be, well, we need to solve for, wait, there's going to be t. We're going to solve for t. So in order to solve for t, we need to do the opposite of PEMDAS, which is, please excuse my dear Aunt Sally, so subtraction and addition comes first, going backwards. So we need to get rid of the 18 because it's adding. So minus 18 to both sides. So we're going to have negative 18 equals negative 0.5 t minus 6 squared. And now we need to do the opposite multiplication division, we have a negative 0.5 multiplied to the outside. So in order to get rid of that, we need to multiply by a negative 2 to get it to be a positive 1. So multiply both sides by a negative 2. Negative 2 times negative 18 is 36, equals negative 2 times negative 0.5 is positive 1, so that would be just t minus 6 squared. Now, in order to get rid of the squared sign, we need to take the opposite of the squared, which is the square root. So square root both sides. So square root of 36 is negative 6 and 6. Don't freak out. Negative 6 times negative 6 is positive 36. Positive 6 times positive 6 is positive 36. So this is true. This is something that y'all need to know. The square root of anything creates a negative and a positive. Alright, so then that's going to be negative 6 equals t minus 6, and 6 equals t minus 6. Now to get t by itself, we need to add 6 to both sides. So that would be 0 equals t, and 12 equals t. Alright, so at 0 equals t, that's when he was jumping out of the water. So we can't do that one. So then our answer will be t equals 12 seconds is when the fish hits the water. Now, next question. At what time did the zombie-eating vampire fish reach its maximum height? Now, shortcut here. We have a parabola, right? The fish jumped, reached its maximum height, and then at the same time, it fell down and hit the water at 12 seconds. So 0 and 12. Now, what's in between 0 and 12? It's maximum height, because it's a parabola. So then, 12 divided by 2 is what? 6. So at 6 seconds, the zombie fish was at its maximum height. Now, next question, what was the zombie-eating vampire fish's maximum height? So pretty much we're just going to plug in t equals 6 into our equation. Alright, and then solve for maximum height, which would be 18. Alright, I'll give that one to you. 18 feet. Now, for what interval of time will the zombie-eating vampire fish be at least 10 feet in the air? In order to do that one, we need to, that's just, the height will be 10. So h equals 10. So we're pretty much the same thing we did for this question here. Set it up as 10 equals negative 0.5 t minus 6 squared plus 18 and solve for t. But I don't want to do that one because I'm getting lazy and I feel like ending this video. So thanks for watching, guys. That's all, and I'll see you all in class.